Today we're going to do something a little different. We are going to tear down what looks like a super simple first-grade English test. But you know what? Hidden inside these questions is a blueprint for genius. It's this surprisingly complex, elegant roadmap for how our minds learn to build everything: language, logic, reality itself. Let's dive in.
Okay, take a look at this. Fill in the blanks. H blank blank E. R blank blank E. You got it, right? Yeah, probably took you, what, half a second? The missing letters are O and P to make hope and rope. Simple stuff. But this isn't just some puzzle. It's a really sophisticated tool, and it's designed to forge a fundamental connection inside a child's brain. So where does a question like this even come from?
Well, it comes from right here, a first-grade English Olympiad workbook. And for the next few minutes, we're not going to treat this like a test. We're going to treat it like an architectural plan, a step-by-step guide for how to assemble a thinking mind from the ground up. So here's how we're going to break it down. First, we'll crack the code of letters and sounds. Then, we're going to build a whole world of words, explore the rules of language, and finally, we'll see how it all connects to logic, to thinking way beyond the words on the page.
All right, first things first, we have to start at the absolute beginning, understanding that letters aren't just squiggles on a page. They represent sounds, and those sounds follow predictable patterns. This right here, this is the bedrock of literacy.
So M blank P, T blank P. You and I, we instantly know the answer is A for map and tap. But what's really going on here, under the hood? Because it's not just about spelling.
It's about teaching this core principle: phonetic consistency. The brain is being trained, literally, to see that app chunk and to know it makes the exact same sound, whether it's in map, tap, cap, or lap. This is how we learn to decode words we have never seen before. It's pattern recognition at its most raw, essential level. And then, of course, they build on it. This next set introduces these common family words: father, mother, sister. The test is really clever here. It uses these familiar ideas to teach more complex spelling patterns, like thur and stir, and it cements them in your memory through repetition and context. So once a kid can decode sounds, the next mission is to attach meaning to them. But, it's not enough to just have a big list of words. The brain needs to organize them into what scientists call a mental lexicon, a personal dictionary in your head.
See, the workbook doesn't just teach words in a vacuum. It teaches the relationships between words. By asking for the opposite of night, or a word that rhymes with things, it's forcing the brain to create this incredible web of connections. Words aren't just dots on a map. They're nodes in a huge network, linked by meaning, by sound, and by how we use them.
Okay, this is where it gets really cool. Which one is the odd one out here? Turnip, apple, tomato, pea. The answer, according to the workbook, is apple. Why? Because it's a fruit and the others are vegetables. This task teaches something called semantic categorization. It's one of the first exercises in abstract thought, the ability to see shared properties, create a mental category, and then spot the exception. That's a skill you need for science, for programming, for basically everything.
Okay, so now we have sounds, we have words, and we have categories. But a pile of bricks doesn't make a house, right? You need the instruction manual. You need the rules for putting all these pieces together to create coherent thoughts. And that, my friends, is grammar.
Just look at this sentence. My blank has 2 wheels. Okay, well, a school doesn't have wheels. A bus has way more than 2. The only logical answer is cycle. So the really crucial thing here is that this question is teaching a child to use both their real-world knowledge, like what things have wheels, and the context clues inside the sentence to find the right word. It's a total fusion of logic and language.
And the workbook builds this skill piece by piece, teaching these unspoken steps. First, you've got to identify the subject. Who or what are we talking about? Like the Taj Mahal in one question. Then you add the action and the glue words, the prepositions, like choosing on in his hat is on the table. Every single one of these simple sentences is a lesson in syntax, the hidden architecture of how we think.
And once that architecture is in place, wow, the questions take a huge leap. They start testing not just the rules of language, but the rules of the world itself. Just consider this one. This isn't about words anymore, is it? This is about reality. This final stage is the grand synthesis. This is where all those language skills we've built finally connect to the outside world, to critical thinking, to logical reasoning. This is the moment where just reading becomes comprehension.
And this is the giant cognitive leap. Can an airplane run on the road? That's not a language question anymore. It's a physics question that requires fact-based reasoning.
What do you do first in the morning? That's a test of logical sequencing. And who is happy with a little smiley face? That's symbolic interpretation, learning that abstract symbols can stand in for complex human emotions.
So just think about the journey we've just seen. We started with decoding the simple sounds in bed, and we ended with questions that require a child to consult their internal model of how the world works, to understand sequences and to interpret abstract symbols. It's an absolutely incredible progression, all laid out in a first-grade workbook.
And that leaves us with one final thought. We all went through this. Every one of us mastered these fundamental building blocks of language, logic, and reasoning. So the question is, as adults, with all the complexity we face every single day, what have we forgotten how to build with these simple, powerful tools?